Okay, so are you guys there?
Yes.
Good. Okay, so let's start off with question number 23. So when a solid is converted directly to a gas, the change of state is called A, freezing, B, melting, C, boiling, D, condensation.
B.
So we're going from a solid to a gas, directly from a solid to a gas. You said B as in boy,
D as in dog.
D as in dog. So if we're going from a solid to a gas, that's condensation? Or,
No.
sorry. You guys remember this, where I said we have gas. What was that? It's E. That's right. Because dry ice sublimes, right? Okay. So the correct answer is E. So if you guys remember the phases, just to remind you, G is for gas. L is for liquid. S is for solid. Okay, so if we're going this direction, from a liquid to solid, that's what? What would that be called?
A, freezing.
Freezing. If we're going from a solid to liquid,
Melting.
okay. Melting. If we go from a liquid to a gas,
That be condensation?
liquid to a gas is condensation.
No.
What is boiling?
Oh.
If you're boiling water, you have water and it's going to what?
Turning into steam. Turning
Okay.
into gas.
Okay, so liquid to gas is
boiling.
okay. Now it's important that you guys, you use the things that you already know, right? Don't overthink it. Okay, so if I'm going from a gas to a liquid,
Condensation.
that's condensation. Let me type. Should have made it so tight, should I? Okay. And then if I'm going from a gas to a solid, that's called deposition. And then if I go from a solid to a gas, that's called sublimation. Okay. Piece of cake.
Just can't overthink.
What was that?
Just got to keep it simple.
Yep, try to keep it simple. Okay, so in a gas, the distance between particles is A, very close relative to the size of the molecule. Close relative to the size of the molecule. Fixed relative to the size of a molecule. Small relative to the size of a molecule. Or very large relative to the size of a molecule. Think about how a gas is going to look in terms of the molecules.
Would it be E?
E is correct. Okay. Can I erase? Move what? Okay. Helium is a or and compound, heterogeneous mixture, element, homogeneous mixture, electron.
C, element.
C is correct. Okay. Air is an or a compound, heterogeneous mixture, element, homogeneous mixture, none of the above. Air. Think about what air has in it. Tell me a gas that air has in it.
Oxygen.
Oxygen, that's one. Okay, anything else?
Nitrogen.
Nitrogen, that's two. Anything else?
Carbon dioxide.
Carbon dioxide, that's three. So that's three different chemicals that it has
Makes
in
it a
it.
compound.
Does that make it a compound? Is that one chemical?
Oh, no.
So let me write that out. So you said we have oxygen, which is O2. We had nitrogen, which is N2. And we had carbon dioxide, CO2.
Would it be D?
Homogeneous. Okay, what is the difference between homogeneous mixture and heterogeneous mixture? Heterosexual. If you're a heterosexual, that means what? You like the same sex or you like different sex?
Different.
Different. Okay, now if you're a homosexual, that means that you like what?
The same.
Okay, so the difference between heterogeneous and homogeneous mixtures, hetero meaning different, so they're different when they inside of each other. So like if we put salt and pepper together, that would be a heterogeneous, right? And then if I put salt and sugar together, that's going to be homogeneous, right? Because it looks exactly the same. You guys remember me telling you the story about Denny's?
Oh, yeah.
Yeah. Okay. Actually, we're going to go back. There's a couple of questions that probably need to know that I overlooked. Okay, so a doctor order is 0.125 grams of ampicillin. The liquid suspension on hand contains 250 milligrams per milliliter. How many milliliters of suspension are required? So how am I going to set up this problem?
So the given is, would it be 0.125 grams?
Okay, 0.125 grams is my given. Okay, now if we look at those units, this is milligrams and this is milliliters. So how do I get from grams to milligrams? How many milligrams are in a gram? Mil. How many of you guys speak Spanish?
Definitely
Me.
not
Just
me.
1,000?
1,000. Okay. So I know that 1 gram
Equals 1,000.
equals 1,000 milligrams. Okay. Then what am I going to do?
I put 0.5 mLs on top and 250 mgs on bottom.
Okay. Okay. You guys have to do the heavy lifting for me.
Two 2.5 mLs.
Okay. Piece of cake? Okay. A nugget of gold with a mass of 521 grams is added to 50 mils or 50 milliliters of water. The water level rises to 77.0 milliliters. What is the density of gold? So let's kind of draw it out. So if we have a graduated cylinder and it has 50 mils of water, Then I drop my goal in there. Then it goes up to 77 mils. So
So you subtract the 77 and the 50 and then
Okay.
divide by the 521 would give you 0.0518 grams to milliliters.
now look at the units, because what did you just tell me? 77 minus 50. And that's milliliters, right? So then
Yeah.
at 22, sorry, not 22, 27,
Yes.
27 milliliters. Now, if we look at those units, they're all grams per milliliter, right? The answer is kind of giving me how I should have it set up. So should I divide it by the 525, or should I divide 525 grams by 27 milliliters?
Grams divided by milliliters.
So I should have grams divided by milliliters, because that's the units that I want. Put the units there, divided by 27.
E 19.3.
Okay, so the correct answer is E. Okay, so that's one of the reasons why we pay attention to those units, because it often will help us, particularly on standardized tests, to sit there and set up the equation right. You guys understand?
Yeah, I see that now. It gives you the way to find the answer.
Yeah. And it's one of the things, standardized tests, they always do that. So pay attention to that. Where my tests, since they're typically, write it out, short answer, they're not going to do that for you. Okay, so which of the following substances will float in gasoline, which has a density of 0.66 grams per milliliter? So what is going to float?
B.
B. Okay, because we know it has a lower density than our gasoline. Okay, and then also, if you kind of take a look at it, all of the other ones are greater than it. So by default, that's going to be the answer, right? So again, standardized tests kind of help us, figure out the answers. What is the oddball, Okay, let's see. There's another one that I want to do. Okay. So match the measurement to the given units. Okay, the first one, milliliters. Is that going to be mass, volume, distance, temperature, or density? Milliliters.
Density?
So it'd be volume, no?
It's going to be volume. That's right. Right? We know density. We just talked about density. What are the units for density? It says it up here. Again, use the answers that are already given to you on the exam to kind of help you through it, right? So we know that that's going to be volume. So that's going to be B. What about millimeters? MM.
Distance.
Distance. What about grams?
E. Density.
Grams is density? Isn't density grams per milliliter?
So would that be A?
It'd be mass, right? Weight, mass. We weigh things in grams, right? Think about what we do, you know, that piece of meat that you're going to cook, you weigh it in grams, right? What about 125 Kelvin?
Temperature.
Temperature, that's right. So that's B. Kilometers or kilometers,
Is that C, distance?
that's C, that's correct. Milligrams,
That's E.
are you sure?
No.
That would be A.
It would be A, it also mass. It ends with grams. Grams is always going to be mass. Don't throw out everything that you guys learned. Okay. So if they had grams per milliliter, which they just told us up there earlier that it's density, right? Density equals grams per milliliter. That's the units for density. So don't assume that by default, all of the answers are, all of them has to be matched up with something, okay?
So density would be like the concentration of something or kind of?
No, it would be like mass over volume, right? It's always gonna be mass over volume. So it's
Oh.
kind of like if we put, it's not quite concentration, but it's mass over volume. Moles per volume, that would be concentration,
Oh,
or
okay,
percent per volume, right?
okay.
Or I guess, yeah, mass per volume, sorta, you know?
And something like that, similar?
Yeah, so density is kind of like concentration, yeah.
Oh, okay.
But usually when we think about concentration, we're thinking about something in something, like Kool-Aid in water. That's concentration.
So it would be like a liquid? It would have to be.
Yeah, it's something in a liquid, yes.
Oh,
Or it
okay.
could be, it also could be something or gases in each other, two different gases in each other. So when we talk about concentration, we're often talking about, mixtures, right? Things that are mixed in together. If we talk about density, density is just that pure substance. Although you can have a density of a solution, right? It's going to be a little bit different density than another solution. Right?
Okay.
Okay. So if we take a look at these units, so we have grams to kilograms. So if 1 gram equals how many kilograms? So here we want to kind of pay attention to which unit is going to be bigger. Is grams bigger or kilograms bigger?
It'd be grams, no?
No,
No?
no. So then it's kilograms. Kilograms are bigger. So a person's weight is in kilograms.
Oh, okay. Yeah, I see.
Yeah. What we weigh in the
Because
little weigh boats is grams, right?
1 pound is about like 2, no? Kilograms?
Yeah,
Oh,
that's right.
Wait, 1 kilogram is about 2 pounds, no?
That's right. 1 kilogram is about 2.2 pounds. Yes.
Okay.
Okay. So we know that this guy is going to be greater. Kilograms is going to be greater than grams. So kilo like a kiloliter or kilo, you know, so we know that's, is that going to be 10 times greater? Is that going to be 100, or sorry, is a kilogram going to be 10 times greater than a gram, or 100 times greater than a gram, or 1,000 times greater than a gram?
10.
Nope. So 10 are usually going to be either deci or, because for 10, so that's our deci, like a decigram or a decagram, right? So it's 1,000 times. It's going to be 1,000 times greater. So kilogram is 1,000 times greater than a gram. So if that's the case, if we have 1 gram, then this is going to be 1/1000, which is just G. Okay, so we just talked about a milligram. Which is bigger, a milligram or a gram? Or I should say, which is bigger, a millimeter or a meter?
Millimeter?
A millimeter is bigger?
No, it's the other way around. A
It
meter
is
is
the other
bigger
way
than
around.
millimeter.
Because think about a meter stick, right? A meter. Can you guys see me? Is my camera on?
No, we see a picture.
Oh, okay. Let's see. Nice.
There you are.
A meter stick. I can't show you a meter stick. It does. A meter stick is like way out here, right? So a meter stick. And then if we look on a ruler, the little indents that we see on a ruler, that's a millimeter, right? So we know that 1 meter is going to be how many millimeters? And again, mil. For those who speak Spanish,
1,000.
1,000. Okay, so let me do this. Just going to put the numbers there rather than. Okay, so a centimeter and a millimeter. A century. How many years are in a century? A
100.
centennial is 100, right? So, and we know that a mil is 1,000. So the difference between 1,000 and 100 would be what?
10.
10. So a centimeter, 1 centimeter is going to be 10 millimeters. Here's that deci, right? So we have 1 decimeter. So that's going to be 10. Deci meaning 10, like a decade, 10 years, right? And then we know that mil is 1,000. So the difference between 1,000 and 10 is what?
$100.
Is 100. Okay, so 100 milliliters is going to equal a deciliter. So 1 kilogram is going to equal how many grams? So we know a kilogram is greater than a gram, and it's how many times greater than a gram? We just talked about it.
1,000.
1,000. That's right. Oh, by the way, I'm very happy that you guys are not afraid of being wrong, because part of learning is being wrong. You learn more when you're wrong than when you're right, right?
See, we
Now-
did learn something.
Okay, a picogram. Pico, let me give you a little hint. Nano means like a nanogram, nano 9, nano 9, nan, both start with N, right? So a nanogram would be 10 to the 9, and that's going to equal 1 gram. So a pico is 10 to the 12th. So 10 to the 12th picograms will equal 1 gram. So that means that which one is bigger? A gram or a picogram?
Would it be a gram?
A gram is going to be bigger, right? Because it takes 10 to the 12th to equal 1 gram. So that means gram is a whole lot bigger. Okay. So In this case, this guy would be 10 to the minus 12, right? Since if we have 1 picogram, that's going to be 10 to the minus 12. So then we know that 1 gram is equal to 10 to the 12th, because I just told you. Okay, now this last one you guys should know because we talked about this quite a bit if you guys watched the lectures. I need 5 CC stat. CC stand for what? What does this stand for?
Is it cubic centimeters?
Cubic centimeters, that's right. So it's cubic centimeters, we know that's volume, right? And we know that 1 milliliter equals how many cubic centimeters?
What?
That's right. They're directly proportional to each other. They're 1 to 1. If you're going into nursing, you need to know that. Okay. Okay, so let's see what else we can do. So was that helpful so far?
Yes.
Trying to brush off all of that dust, right? Okay, so which of the following is a chemical reaction? A, cutting a rope, bending a steel bar, making a snowman, burning sugar, melting gold. A chemical reaction.
Burning sugar.
Burning sugar, that is correct. Which one of these is a physical reaction? Baking a cake, dry ice subliming, fermenting grapes to produce wine, digesting your meal, tomatoes ripening.
Would it be B?
That is correct. That's just a phase change. Let's talk about that. Good job.
So Dr. Henry.
Yep.
How come cubic centimeters and milliliters, or like why the difference in name?
So a milliliter was actually made upon a cubic, everything was actually initially started with a cubic meter. And so a liter was actually the first one that came about a cubic liter. How much space was it being occupied? And so then they did the calculations and stuff like that. And it ended up turning out that a cubic centimeter ends up being exactly the same thing as a milliliter.
Oh, okay.
Good question. So I'm going to skip this one, I believe.
Why are we skipping this one?
Partially because you guys, it's good to know, but it's not necessary to know for this level. You know what I'm saying? So I'm trying to give you the stuff that's going to be necessary for you guys to know. But we can go over it if you want to. It's real simple.
Well, I mean, if it's not something that's going to be necessary for the test, we can go to something else.
Okay. Yeah. So you guys should do this one. I'll let you guys figure that one out on your own, right? Same type of questions. Okay, so which of the following elements is a metal?
Would it be E?
Phosphorus, or did you say E as in Edward, or did you
Yeah,
say
Edward, is it? Maybe? I don't know.
nope?
D.
It's D. Strontium is a metal. That is correct. D as in donkey. Right? Phosphorus is a non-metal. Okay. Which of the following is a noble gas? Everybody wants to be like them.
Argon?
Location. What was that?
Argon?
Argon. That is correct. Argon is correct. Argon is a noble gas. So the elements in this list with chemical properties similar to magnesium. So the element in this list with chemical properties similar to magnesium.
Would it be A?
Nope.
No.
D.
D as in donkey. Strontium. They both are going to end up their alkaline metal. They're in group 2. Okay. Which of the following describes the which of the following describes a subatomic particle is correct? Which of the following description of a subatomic particle is correct? A proton has a positive charge and a mass of approximately 1 AMU. B, an electron has a negative charge and approximate mass of 1 AMU. C, a neutron has no charge and its mass is negligible. You guys know what negligible means, right? It means that you don't take it into account. D, a proton has a positive charge and its mass is negligible. E, a neutron has a positive charge and a mass of approximately 1 AMU. Proton. What charge is a proton? Positive, negative, or neutral?
Positive.
Positive. Okay, so we know by default it's going to either be A, D, right? Because both of those are correct so far, right? What's the charge of a neutron?
Does it even have one?
It doesn't have a charge. That's right.
Neutral.
So we know that E is wrong, right? And then we also know that, well, possibly C is wrong. So now, what's the charge of electron?
Negative.
Negative. So we have a possibility of B being correct, right? Okay, so we can get rid of just E so far. Okay, now what makes up the mass of an atom?
Proton and a neutron.
Protons and neutrons. So we know that they're not negligible, so we can get rid of C, we can get rid of D. So that means that it's either, well, and we know that B doesn't make up the mass. So then we got rid of B, C, D, and E.
Leaves you with A.
Leaves me with A, right? So use the things that you guys can remember to help you find the answer. Does that help? Yeah? No? Maybe?
Yeah, it does.
Yeah.
Okay. So the mass of an atom can be calculated from, you just told me,
Protons.
Protons and
Neutrons.
Neutrons.
neutrons. So the correct answer is B, right? Oh, this is fun. Nuclear chemistry, sort of. So the correct symbol for the isotope of potassium is, sorry, the correct symbol for the isotope of potassium with 22 neutrons is so what is this lower number? What should this lower number be down here?
The atomic number, no?
It should be the atomic number. So what is the atomic number of potassium?
19.
19. So that means we can get rid of this one, we can get rid of this one, and we can get rid of this one. Okay, so,
E.
okay, but what is the top number? What does that top number equal?
Last number,
The
no?
atomic mass.
The atomic mass. And we know the atomic mass is made up of what?
Protons and neutrons.
Protons and neutrons. So I need to add the protons and the neutrons together. So if I add them together, what do I get?
42.
22 plus 19.
41.
Okay. We got to work on that math.
I was adding the 2 neutrons.
Okay. So the correct answer is A. Okay. Which of the following gives the correct number of protons, neutrons, and electrons? Okay, so how can I determine the number of protons?
The atomic number.
The atomic number, which would be the upper number or the lower number?
Lower.
The lower number. Okay, so it has to have 50 protons. So it's either C, so we know that A is wrong, B is wrong, and D is wrong. Okay, so if it doesn't have a charge, how many electrons does it have to have?
50 as well.
It has to have 50 as well. So it's either E or C, right?
Wouldn't you subtract 118 from 50?
So I subtract 118 from 50. So
The
that
answer is
would
going to be C.
correct answer C. Okay. You guys got that?
Yeah, that makes sense.
Okay. Isotopes are atoms of the same element that have A different atomic number, B, the same atomic number, but a different number of protons, C, the same atomic number, but a different number of electrons, D, the same atomic number, but a different number of neutrons, E, the same atomic number, but a different number of protons. So first off, if you see anything that's mentioned twice, right, that's exactly the same thing, chances are that's wrong. So do you guys see something that's mentioned twice?
B and E.
Okay, so B and E. So we know that those are wrong. Okay, so then what is it?
Probably
So
be
the
C,
atomic,
huh?
what was that?
Is it C?
Nope.
Huh?
Because we know that different number of electrons basically means that your charges, you have charges associated with that. That's not an isotope, that's an ion, right?
Okay.
So it's either A or D.
D.
It's D, right? Because we know the atomic number represents the number of protons. The protons define the element. They let us know that that element is that element. So carbon is always going to have how many protons? I mean, yeah.
6.
It's always going to have 6. We know carbon is defined by 6 protons, okay? So the protons are going to be the same always. They're never going to change, but the number of neutrons can change. That's how your mass changes, right? That's what the definition of an isotope is. Okay. Okay. A sample of chlorine has 2 naturally occurring isotopes. The isotope Cl35, it has a mass of 35, makes up 78.8% of the sample. The isotope Cl37 makes up 24.3% of the sample. What is the average mass of chlorine? So how would I go about doing this? That's okay.
Would you add the 2 masses together and then divide it by 2?
Nope. Because they're not equal concentrations, right? They have different percentages. So that's kind of like, so how do you take the average of your grade? Do you just say, okay, I got an A and I got a C, I'm just going to add those together, right? Even though you have 20 A's and you have 2 C's, would that be?
Mhm.
Do you guys understand what I'm saying? So let's say, for instance, if you have 5 A's, so you have 5 A's, all of your A's were like 95, right? Each one was 95. And you got 2 C's. And you have 2 C's, right? And each of your C's are going to equal 70%. Is that going to equal 80%? Or 95? You said 95 plus 70? Is that how you would calculate your grade? I would just take 95%, but there's 5 of them, right? So it's sort of like that. Okay, so I need to take into account the quantity that I have, right? That percentage that I have of them that are A's, right? So if I take a look at this, I have 5 over 7 that are A's. So I multiply that times 95, right? And then I take 2 times 7, 2 divided by 7, and multiply that by 70. And then I'd add that together, and that would give me my grade. Okay, so this is going to be kind of the same way. So here we have the percentage that is mass 35. So we need to change that percentage to a fraction. So that's 35 times change that to a fraction or a decimal. It's going to be 7 0.758. Multiply that by 35 plus 37 times 24.3. Oops. Sorry, got to change that to a decimal. 0.243. And then we're going to add those together. Can somebody do the heavy lifting for me?
$35,521.
Okay. So now here's the tricky part, right? So you guys say it would be E, right? How many sig figs would it be?
2.
Are you sure? So that's
Three.
1, 2, 3. That's 1, 2, 3. That's
3.
1, 3. Right? So 3 sig figs. Remember,
Answer
if I
would be
give
D.
you 5, that's right. So the correct answer would be D.
Those damn sig figs.
Okay, so the correct answer would be D, as in donkey. Okay, don't forget the sig figs. I think there's 2 questions that are pertinent to sig figs. Okay. A sample of silicone has 3 naturally occurring isotopes. Actually, we can do this with this. So I was going to save it, have you guys do the calculation. The sample of silicone has 3 naturally occurring isotopes: Si28, which has a mass of 28, Si29, which has a mass of 29, and then Si30, which has a mass of 30 AMU, 30.10 AMU. The average atomic mass of silicone is 28.1 AMU. Which isotope is most abundant? A, Si28, B, Si29, C, Si30.
So what does abundant mean again?
Abundant means the one that you have the most of. Abundant. So which one would you have the most of?
Would be C.
Don't overthink it. Look at the number of the average. The average tells you which one it's closest to.
So A.
A, right? Because it's 28.1. So it's closest to 28. Okay. If it was 28.9, which one would it be closest to?
B, 29.
Right. Okay. So that average tells you which one it's closest to. That's going to be the one that's most abundant.
Yeah, I can't overthink.
Yeah, there's a tendency. It's really easy to overthink. You're like, oh, it has to be this really weird calculation that I can't figure out. So I'm gonna.
Just seemed too simple to be A.
Yeah, exactly. And then the answer is A, right? Don't overthink it. Okay, the number of electrons in the outer energy level of a neutral element, neutral atom of boron is A, so it has an atomic number of 5, if you can't find it, is A2, B3, C5, D8, E10. The outer level, the outer energy level.
Is it B?
The correct answer is B. That's right. There's 3. So if you look on your periodic table, you count over 1, 2, 3. In the second period, that's going to be your outer energy level, right? Okay. Electron configuration. Okay. The electron configuration for potassium, atomic number 19, is 1s, 2s, let's say 1s2, 2s2, 2p6, 3s2, 3p7. So here's the secret. If you guys remember, the S sublevel can only hold how many electrons?
2.
2. It can only hold 2 electrons. The P sublevel can only hold how many electrons?
2.
Now, if the S holds 2, the P has to hold how many? Because there's 3 orbitals, and each orbital can hold 2 electrons.
6.
6. So P holds 6. So we know that A can't be right because you have P having 7. So that's wrong. Okay. So we know that the
Take
D
out
orbital,
C.
we can take out C. Okay, yep, we can take out C. Okay, so we've got rid of 2 of those already. Okay, so if we go to our periodic table, can you mind if I pull up the periodic table?
Go for it.
Okay, let me pull it up.
So these are pretty much like coordinates, no? To like a certain atom or
Yeah, it is kind of like coordinates, for it, right? So if we remember, I know this is going back. I'm in a little trouble with controlling my mouse there. So that's the S. This is the P. This is the D. And this is the F. Okay, so that's F. That's D. That's P. And this is the S. Okay, S holds 2, 1, 2. P holds 6. D holds 10. F holds 14. Okay, so here we have, starting off at the very beginning, that's 1s, 1s2. Then we have second period, that's 2s2. So that counts for these guys. This is 2p6. Three S2.
3p6.
3p6.
Potassium, right?
And then potassium is K. So there's only
4s1.
4s1. Okay. Now, another way that we can look at this is we can count the number of electrons total. So that's 2, that's 4, that's 10, that's 12, that's 18, that's 19 total
19.
electrons. Okay,
Which is what K is.
that's right. Okay, so then if we go back to the question,
You can just count the number of electrons and you'll have your answer.
yep, you can check that. That's what another way of looking at it. That'll help us get rid of some things as well too. So then that's, let me erase this so you guys see the problem now. So, and we said we already got rid of this one.
So B.
Okay, so that's 1s2, 2s2, 2p6, 2s2, 3p5, right? And Here, we know that 3p5, it has to fill up first, right? So that one can't be right.
Yeah, as I say, that doesn't make sense.
Yep. So that one's wrong as well, right? Because we should have 3p6. So the
That's
next,
interesting because it adds up to 19 too.
yeah, it kind of got you. So this one has 1s2, 2s2, 2p6, 3s2, 3p6, 4s1.
That'd be D.
Okay, so the correct answer is D. Okay,
So you can count it to eliminate everything else, and then you have to look back to see, make sure it says P6 or P5, like where you're
that's
at.
right. Exactly.
Cool.
Okay. The number of dots in the electron dot structure for carbon.
Is it D?
Did you say B as in boy or D,
D
as
as
in
in Daniel.
D as in Daniel? That is correct. D is correct. Because it's 4 valence electrons, so it has 4 dots. Good job. Okay, so we need to match the metal with what it is. I mean, sorry, match the element with what it is. Okay, so, and it could be multiple in this case. You can have multiple ones that are correct. Okay. 52, sodium. Is it a noble gas? Is it an alkali metal? Is it a non-metal? Is it an alkaline earth metal? Or is it a transitional element? Or is it a halogen or transitional metal? So sodium,
Is it B maybe?
Alkali.
it's B. That is correct. Alkali, right? Alkali sounds really strong. You know they're very reactive. Alkali metals are very reactive. They're group 1 metals. Good job. What about, that's B as in boy. Okay, what about argon?
Noble gas.
That's right, A. What about bromine? Bromine. And also it's also a non-metal since it's a gas, right? So it's A and C, okay? What about bromine?
Is it A?
Nope, it's not a noble gas.
Oh.
Remember, noble gases are at the very end, group 18. Those are all your noble gases. Those are the cool kids. Everybody wants to be like. So somebody said halogen. That's F. That is correct. They're the ones that's right next to it. They want to be like the noble gases. They're one away, right? So those are your halogens. They raise hell because they want to be like the the noble gases. Okay, so they're also nonmetals, right? So it's A, F, and C. Copper.
Transition.
E?
That's right, it's E. That is correct. What about 56? Magnesium.
D.
D, that is correct. 57, phosphorus.
B.
You said B as in boy?
Yeah.
Are you sure? Phosphorus.
Is it C?
Phosphorus is C, right? Because if you look where phosphorus is, P, it's a non-metal, right? Okay. Okay, so now we're going to do nuclear chemistry, the last thing that I talked about. Which of the nuclear symbols for the radioactive isotope copper with a mass of 60? So what does that lower number have to be?
Atomic number.
What is the atomic number for copper?
29.
29. So we know we can get rid of B, we can get rid of C, we can get rid of D, okay? So it's either A or E. What's on top? What does that top number has to be?
60.
60. Okay, so then it's A, right? Simple. Okay, so nuclear chemistry, again, the nuclear symbol for helium, for He2, is also the symbol for designating a proton, a neutron, a gamma ray, a beta particle, or an alpha particle. Well, we know the symbol for a proton is not helium, so we can kind of get rid of that one, right? We know the symbol for that would be P 1 0. So that would be the symbol for a proton. We know that the symbol for a neutron is N 1 on top and a 0 because neutron affects the mass. Gamma rays, well, gamma rays is a combination of your proton and your neutron, so we're not going to have that one. Our beta is a negative charge, which is E minus 1 and 0. And then by default, our alpha particle is going to be helium. 4 2. So the answer is E, as in Edward. It's for any element. Anytime that they say alpha particle, an alpha particle is just that helium isotope. Okay, so alpha is that helium isotope. It's also considered to be a positively charged particle, even though it has neutral components, right? So a beta is always going to be the electron, right? And so that's going to have a negative charge down here. Okay, so the symbol for 0E minus 1 is what? D as in donkey? Okay. Are you guys still there?
Yeah, isn't it gamma?
Nope. It's D. We just talked about it up here.
Oh, it looked like your gamma ray was pointing to it.
Oh, I'm sorry.
So I was
Gamma.
confused.
I'm sorry. Gamma is a combination of both. It's a combination of A plus B. That's going to be your gamma.
Okay, that makes sense then.
A plus B is gamma. Okay, so this is my bad. Okay,
Messing with me.
sorry. Okay. Oops. Can I get it to move? Okay, so what is missing in the nuclear reaction shown below? Now, the way that we would do this calculation is these guys have to add up to this, what's on the other side, right? So what are we missing up here?
Missing a 1 to make it 14.
Okay, so how can I get 1 up top? What would I use? An
A
alpha?
pencil.
A pencil?
You just draw the line.
Is it E?
Because what is a neutron is what? It's 1 over naught, right? Wouldn't 1 over naught equal the same thing as this? That'll be 14 and 7, because 7 plus,
Looks
Okay.
even to me.
okay, so then we know that that's a neutron, right? One second. Okay. Okay, number 62. So the correct answer was C. So you guys, for that last one. So number 62, what is the radioactive particle released from the following nuclear reaction? So what is the number that we need up top?
So it's got 4 over 2.
Oh, it's 4 over 2, which we know is what? So what has a mass of 4 and a 2 atomic number?
Helium.
Helium. So we know that this is also called
Alpha particle.
alpha particles. That is correct. Okay. Clear? Okay. So a sample of ceruleum 141 for a diagnostic test was dissolved in a saline solution to an activity of 4.5 millicuries per milliliter. If the patient is undergoing tests, needs a dose of 10 millicuries, how much solution should be injected into the patient? So what is my given?
4.5 millicuries over 1 millimeter.
Well, that's our activity, but our given would be,
Needs 10.
it'd be
Sure.
10. That's right. So 10 millicuries. Okay. So this is our conversion. So we have
1 millimeter on top and 4.5 on the bottom.
okay.
2.22222.
Okay, so 2 sig figs, right?
Yes.
2.
So C.
Okay. Okay. Half-life. So half-life is the half-life of a radioisotope is 1/2 the time it takes for the radioisotope to completely decay to a non radioisotope. A. B. The time it takes for the radioisotope to become an isotope with 1/2 the atomic mass of the original isotope. C. The time that it takes for a radioisotope to become an isotope with 1/2 the atomic number of the original isotope. D. The time it takes for the radioisotope to lose 1/2 of its neutrons. E. The time it takes for 1/2 the sample to decay. So this is basically dealing with radioactivity, right? And so you're looking at the decay rate, right? So it's the time that it's going to take for 1/2 of the sample to decay.
E.
Yep, it's E. Okay, so krypton has a half-life of 35 hours. How many half-lives have passed after 105 hours? So if one half-life is going to be 35 hours, then X half-life is going to equal 105 hours. So let's solve for X. So if I solve for X,
Would it be 105 divided by 35?
yep, 105 divided by 35. Okay. So the correct answer is C. Okay. So if the half-life of bromine is 25 minutes. So that's where we get half of our product, right? So how much of 4.0 milligram sample is still active after 75 minutes? how many half-lives would that be? It'd be 3 half-lives. Okay. So you said it would be 2 cubed? Okay. So then 2 cubed divided by what? So we'd have 2 to the 3rd power divided by 4. Okay. So because since we're starting off with 4 milligrams, and what do you guys get? 2.5? You said 2.5? So 2 cubed is 8. Is that right? So piece of cake. Okay. How you guys doing? Good so far? How many hours have we gone? What time is it? Okay, we're gonna do a couple more. And then what I'll do is on Thursday, for those who want to, I will set up another time for you guys to come in and we can answer some of the other questions.
Sounds good.
Sounds good? Okay, so let's do compounds and bonds. Okay, how many electrons will aluminum gain or lose when it forms an ion? Aluminum. What's going to be the charge on aluminum? Aluminum. Starting.
Would it lose 3?
It's going to lose 3. That's right. So the correct answer is D. What is the symbol for the ion with 19 protons and 18 electrons? So we know that protons define the element. So what is the element?
Potassium.
Potassium. So if it has 18 electrons, so what would be the charge? Would it be a negative charge or would it be a positive charge?
Positive.
Okay, that's correct. Okay, the correct formula for a compound formed from the element aluminum and oxygen is AlO, Al2O, Al3O2, AlO3, Al2O3. What is the charge on aluminum?
Is it 3?
So it's a 3 plus. And what is the charge on oxygen?
-2.
-2, that's right. So if these guys are going to balance out,
It's gonna be C, Al3O2.
Are you sure?
No, oh, sorry, wait, other way
E,
around.
no?
The other way around. That's right.
It's E, Al2O3.
That's right.
You just take their, what their charges are and flip them.
That's right. Cross multiply, right?
Are you eating fried chicken?
I'm eating wings,
Nice.
spicy wings. Yes. So the compound magnesium chloride is named, oops. Okay, the compound MgCl2 is named A, magnesium chlorine, B, magnesium dichloride, C, magnesium 2 chloride, D, magnesium chloride, E, dimagnesium chloride.
C,
Are you sure? Where is magnesium located? Is it a transitional metal?
It's a metal.
But is it a transitional metal?
No.
No. So group 1 and group 2, we never use the Roman numeral for, because we know that group 1 metals are always going to be what charge? +1.
positive,
Group 2 metals are always going to be what charge?
+2.
+2. So we don't have to put the Roman numeral 2 there. So then
It's D,
D is the correct answer. Again, don't forget the things that you guys learned. Okay. Fe2SO43 is called
would it be C, iron 3 sulfate?
iron 3 sulfate is correct. Because we know sulfate has a +2 charge. So that means that the iron 3 has to have a +3 charge. I'm sorry, sulfate has a -2 charge. Iron has to have a +3 charge. So it has to be iron 3 sulfate. Which of the following elements do not exist as a diatomic molecule? Is it hydrogen, nitrogen, chlorine, oxygen, or carbon?
Is it carbon?
It's carbon, that's right. Okay. Choose the best electron dot structure for OCl2.
D or E?
The correct answer is E as in Edward. It's not D because chlorine prefers not to have a double bond. It always likes to have a single bond.
When it's been I'm trying to remember all this, the double bonds. Because
Well,
chlorine,
yeah, well, because chlorine only needs one electron, right? Chlorine only needs one electron. Oxygen needs two. So if he gets one from chlorine and one from each of the chlorines, it has its two that it needs, right? Chlorine only needs one. It's not going to want to share more than one unless it absolutely must. It has to be really, really forced into it. And the goal is you want to try to get to its octet. Everybody wants to get to their octet. And so you want to find the easiest way to get to your octet. You only want to use double bonds if you have to use double bonds because that's more energy.
that makes sense.
Sorry to eat in front of you. I'm starting, and then I have to meet my next rendezvous right after this. So let's go to Kalinga. Okay, the correct name of the compound in Cl3 is A, nitrogen chloride, B, trinitrogen chloride, C, nitrogen 3 chloride, E, nickel chloride, D, nickel chloride, E, nitrogen trichloride.
E.
Correct answer is E. That's right. So we use prefixes only for nonmetals when all nonmetals are together. So which of the following substances contain a nonpolar covalent bond? H2O, NaCl, NH3, MgF2, N2. So would nonpolar be equal sharing or uneven sharing?
Uneven?
Are you sure?
No.
Equal sharing.
Yes. So nonpolar means that we're sharing evenly or equally, right? So who's going to be sharing evenly?
B.
Are you sure? Because isn't B sodium chloride? Isn't that taking and giving? So is that sharing evenly? It just takes it.
Then it gives it.
And it gives it. Is that sharing evenly?
Depends on how much you take and give.
No, it's all take and give. One is taking, the other one is giving, right? So there's no sharing there at all.
So would that be E with just nitrogen?
That's right. It'll be E. So we know that ionic bonds will never be polar. Will never be polar covalent. They're always going to be ionic. So if it's a metal and a non-metal, it's going to form an ionic bond, except for beryllium. Boron. Okay, so these will be the last two. Which of the following compounds contain a polar covalent bond? Actually, we'll do these last three. A, sodium fluoride. B, hydrogen chloride. C, bromine gas. D, magnesium oxide. E, oxygen gas?
B.
B is correct. So that's an example of uneven sharing. Because chlorine is going to want it more than the hydrogen, the electron more than the hydrogen. Which of the following compounds contain an ionic bond? A, ammonia, B, water, C, calcium oxide, D, hydrogen gas, E, methane gas. What's the rule about ionic bonds? It has to be a what and a what?
Metal and non-metal.
It has to be metals and non-metals. Okay. Which one is a metal and non-metal? A, B, C, D, or E?
C.
C is the correct answer. If the electronegativity difference between X and Y is 2.1, the bond between element X minus Y, or X, Y, is ionic or nonpolar? Ionic.
Non-polar ionic.
Is there such thing as nonpolar ionic?
No.
No. It's just ionic. Nonpolar, again, means that you're sharing evenly. So there's no such thing as sharing evenly if you're taking the electron. It's kind of like you come up to me and steal my wallet, take $100 out of my wallet. Am I sharing my money with you? Or did you just take my money?
You're sharing because you didn't take it back.
Better than last time?
Yep.
Okay. Did it help?
Yeah, I did.
Okay.
Do it again on Thursday.
Yeah, we'll do it again on Thursday. Let me get back to you with the time. It'll probably be around noon time if we do it.